Hello everybody, welcome to my presentation of STP, Spanning Tree Protocols. And until now, we have learned how a switch is worked. The switch is worked based on the MAC address, okay, and itself making a MAC address table. And we are figuring out all other interface if the frame is a broadcast frame, okay. This is the basic mechanism of the switch sending or forwarding the Ethernet frames. And then this is only one switch. But if the network contains more than one switch, then if only one link interconnect different switches, that means there's no redundancy. Okay. If this link is broken, that means the two switches were disconnected, the communication will disrupt. Okay, so maybe we need a reliability. So we may connect more than one link between different switches. So that's a redundancy. But this redundancy also will cause a loop. The loop will lead to some error scenarios, error problems, such as the broadcast storm and so on. So how to solve this problem? We need a redundancy, and we need to avoid errors of the looped network. We deploy the STP, the spanning tree protocol, to avoid this problem. Okay. And in this chapter, we first will discuss what problem will happen when the network is looped. And then, second, how the STP is worked. And then, later, we will discuss how to configure the STP. Okay. And first, this is redundancy. If we only connect one link between different switches, so that means that's without redundancy. Okay, so if this link is broken, then this switch C, is disconnected from the rest of the network. Okay, this is unreliable. The reliability is not good. So usually in our network, in switch network, we use redundancy. For example, the switch C use two links to connect to different switches, one to switch A and one to switch B. Then these two links provide redundancy. Okay, but this redundancy also leads to a problem. There's a loop. Okay, first, if switch E sending data to switch B, then switch B can forwarding to switch A, and then switch also can forwarding back. This is a loop. We call the loop. Okay. So what's the loop will cause? What problem the loop will cause? Yeah. First, the broadcast storm. For example, between switch A, switch B, and switch C, there's a loop. Okay. There's redundancy connections. So when the host A, first sending out a broadcast, this is a broadcast. That means the destination of this frame is FFFF, all ones, okay, 48 ones destination MAC address. So when the switch B receives this broadcast, then what will happen? The lure of the switch forwarding the frame. That's if this is a broadcast, then flooding out all the other interface. Okay, so the frame will flooding out this interface and then flooding out this interface. Okay, so we first see this interface, the flooding out of this interface. Then switch A received, and then the send lure. Switch A receiving a broadcast, then flooding out all other interface. Then we are flooding out this interface. And the switch C is the same, flooding out all other interface. And then back to switch B. And then switch B still receiving a broadcast, then flooding out again and flooding out back to host A. Okay, so this process will not stop. The packets, the Ethernet frame, will forwarding again and again between these three switches. Still, another direction. The first broadcast flooding this out, this interface out. Then switch C will flooding out, also flooding out, and then flooding out to switch A, then back to switch B, and switch B also will flooding out these two interfaces, and then looped again and again. Okay. This is the broadcast storm. This broadcast will not stop. And as we know, the switch processing the frame forwarding so quickly. So all the bandwidths of these links between these three switches will be used up. Okay. And all the other normal frames cannot forwarding between them on. Okay, this is the broadcast storm. One biggest problem. Okay, biggest problem of the switch network loop. Okay, and then the second problem is the MAC address instability. MAC address table flapping. Okay, again the broadcast. The host A sending a broadcast out. So switch B will learn the source MAC address of AA from G003. Okay, so we will fill in this MAC address table, this item. Okay, right. Then the broadcast will sending out and then back from this interface. Okay, switch B then learned the source MAC address. This is the same frame learned from this interface. Okay, so learned from this interface. So the previous item is wrong now. So this item is deleted, and then a new item added into the MAC address table. Okay, of course, then again, of course, still learned from this interface, but we have learned the broadcast will flooding out other interface, still flooding out other interface, and from this way we are looped back on this interface. Okay, then switch B learned from this interface. For example, it's 001, and then this item also needed to be relied. Then this MAC address is from 001, right? But as we know, the broadcast storm, this packet will looped again and again, and the green also, that's the clockwise, will also looped again and again. So the switch B sometimes learned the source MAC address from G002 and sometimes learned from G001. And then the switch B is busy delete and add MAC items in its MAC address table. Delete, add, delete, add, delete, add. Okay, this MAC address is flapping, sometimes from G001, sometimes from G002. Okay, again and again. This is the MAC address instability. Okay, these two, the broadcast storm and the MAC address flapping, this is the biggest problem that may be caused by the switch network loop. Okay.